we are going to do lesson 3. All right. Hi, this lesson, we are going to solve cube root equations algebraically. Now, for prior knowledge, I just want to remind you that with cube roots, as opposed to square roots, we don't have to worry about having negative radicands. The cubic root of 8 is 2, but additionally, the cubic root of -8 is -2. I don't have to worry about restricting domain. The domain of cube roots is all real numbers. So again, our objective is to solve cube root equations. Cube root equations are also radical equations, just like we've been studying before. They're equations, so they're going to have equal signs, and they involve a radical. So our whole objective, remember, is to isolate that radical expression. I have to isolate it, get it by itself, and then I can go ahead and raise both sides to the appropriate power. We're going to be raising it to the power of 3, obviously, because a cube root, its inverse, is a cube. Then we'll go ahead and we'll solve the resulting equation. And then lastly, we will check for extraneous solutions, checking to see, okay, does the left side equal the right side? Now, we don't have to worry with cube roots, again, about negative radicands giving us imaginary values. So, you know, that's something that we're not going to have to worry about in this instance. So here's our first example, and it's fairly basic. We have the cubic root of x is equal to 2. So again, remember, step 1 is to go ahead and isolate that radical. Well, that's already done. I already have the cubic root of x by itself. Step 2, I'll go ahead and raise to the appropriate power. So I'm going to cube each side because I want to undo that cubic root. So I have x is equal to 8. Now in this example, we don't have to solve anything. Like I said, this is a very basic, that's a V, I promise. And then step 4, you want to go ahead and check. You know, is 8 the answer? So I can check just by plugging it in. What's the cubic root of 8? That's 2. Yep, that's the answer. Very simple. So again, a lot of similarities to solving square root equations. It's just instead of, you know, raising to the power of 2, we raise to the power of 3. Now, with square root equations, a lot of the times we had to worry about, you know, if I square a negative, you know, most likely that's going to produce an extraneous solution. Here in this example, I have the cubic root of x equals -4. Again, nothing to isolate. I'm just going to go ahead and cube each side to get rid of that radical. We get x is equal to -4 cubed. So -4 cubed, 4 squared, 16. 16 times 4, 64. So I get a -64, right? Negative times negative is positive. Positive times negative is a negative. So I'm just going to go ahead and check what is the cubic root of -64. And indeed, in fact, it is a -4. All right, here is a more involved problem in this equation. So we have 5 times the cubic root of 3x plus 1 is equal to -10. So again, step 1, I'm going to go ahead and isolate. So how do I isolate that radical? Well, again, I'm just going to get rid of the 5. I need to undo the 5. So I will divide by 5 on both sides, giving us the cubic root of 3x plus 1 is equal to -2. All right, radicals isolated. What do I do next? Go ahead and raise to the appropriate power. So I will cube each side. And I get 3x plus 1 on the left is equal to -8 on the right. Step 3, go ahead and solve. So here's where I will just use inverse operations to isolate x. Remember, undo addition, subtraction first. I'm going to go ahead and subtract 1 on each side. 3x is equal to -9. divide by 3 on both sides. And we get x is equal to a -3. Step 4, I'm going to go ahead and check. If I plug in -3, does it give me, is the left side equal to the right side? So I'm checking over here. Okay, so 5 times the cubic root of 3 times -3 is -9. All right, I just plugged it in. -9 plus 1. What is this equal to? Well, 5 times cubic root, that's -8. So that's -2. And this equals -10. So is the left side equal to the right side? You betcha. So -3 is our answer. Okay. All right. Here is a practice problem. You can go ahead and pause the video, and I'm going to show you the answer. Again, if you're watching this live, you can write this down and then practice it and come back to it. Due to our limited time, I'm not going to have time to go ahead and do a pair deck on this one. But you can pause it. You can write this one down. You can always check back. And I'm going to show the answer right now. You can always jot down the answer to check and see if you get it right. Okay, so here is the solution. Okay, so x equals 6. On this one, I mean, not much. You're going to subtract 7 on both sides. You'll cube both sides, and then you'll solve 5 minus x is equal to -1. And you get x equals 6, and you check it. That's the answer. Okay, here's another example. If you want to go ahead and write this one down. And this one, they're just getting cute. They're checking your translation language. Can you go from a rational exponent to radical form, which is no problem. Whenever I see a fractional exponent or I see a radical, I know that I can turn that into a fractional exponent. So this is 8 minus the cubic root of 2x plus 5 is equal to 3. That's what this is. So that's just the first part, is just kind of translating that exponent language. So again, I'll do step 1. I'm going to go ahead and isolate my radical. I guess 2 ways you could do this. I'm going to go ahead and subtract 8 on both sides. So we have a negative cubic root of 2x plus 5, which is equal to -5. And then I'm going to divide both sides by a -1. Now, if you wanted to just make that cubic root positive right away and add it to the other side and then subtract 3 on both sides, you could do that too. And you would end up with the same thing. Cubic root of 2x plus 5 is equal to 5. So step 1, my radical is isolated. Step 2, raise to the power. So I'll cube both sides. Cube, cube. So we get 2x plus 5's equal to 5 cubed. 5 times 5, 25. 25 times 5, 125. There you go. We'll go ahead, we'll subtract 5 on both sides. We get 2x is equal to 120. Divide by 2. X is 60. All right, and all of that was step 3, solve. Okay, is that the answer? Is it the answer? Well, I need to go ahead and check. So if I plug in 60, let's see. 8 minus the cubic root of 2 times 60. I know that that's 120. Plus 5. Does this give us 3? So 8 minus the cubic root of 125, right? 120 plus 5, 125. And the cubic root of 125 is 5. So 8 minus 5, is that 3? Only on Wednesdays. Today's a Wednesday. Okay, so 60 is our answer. Not too complicated. And again, if you've mastered solving square roots, this should be simple, unless you really struggle with cubing stuff, which is a little bit tricky because we're not used to doing it as much. Again, here's another practice problem. Oh, sorry. You can go ahead and write this one down or pause the video right now and give it a go. I'm going to show the answer here in a bit. All right, so hopefully you pause the video. Here is the solution to the practice problem. Answer is 6. Again, I think the last practice problem was 6. All of the practice answers are going to be 6. I'm just kidding. They're not. They may be. I don't know. Okay, so on this one, we add 4 to both sides to isolate the radical. We're going to cube both sides, and we get 5x minus 3 is equal to 27. From there, that's just a linear equation that you guys were doing when you were mere bebes in 7th grade. You can do that. X equals 6. Okay, and then check it, and of course, it's good. Here's another practice one. If you want to go ahead and pause the video, you can try this one. Okay, hopefully you pause the video. Here is the solution. Is it 6? It's not 6. It's negative 75. Divide by 2, cube both sides, and it's just like the rest. Not a lot of curveballs in these lessons. Okay. Here is the next example. We got 2 more examples for you. Here we have the cubic root of x squared plus 9 is equal to 2. Ooh, they're giving us radicals, or sorry, quadratics inside the radicand. Okay, so step 1, isolation. I don't have to do anything to isolate it. It's ready to go. Step 2, I'm going to raise it to the appropriate power. I'm going to cube each side. So this gives us x squared plus 9 is equal to 8. Step 3, solve. I'm going to subtract 9 on each side. And we get x squared is equal to negative 1. Huh? X squared equal to negative 1? Whenever you square something, what's the output? It's always, exactly, it's always positive. So right here, this should throw up some red flags that you're going to have extraneous solutions or no solutions. I mean, you can go ahead and solve this. I mean, I'll take the square root of each side, take the square root. So we get x is equal to a plus or minus square root of negative 1, which you should recognize the square root of negative 1 as I. That is the definition of I, imaginary. So plus or minus 1i. Both of these are going to be extraneous. So no solution. Okay. And if you want to write it in set notation, it's with the set brackets and then a 0 with a slash through it. No solution. Okay. All right. Another example. Here we go. The last, but not the least. We want to solve this equation. I have the cubic root of x squared minus 7. Minus 1 equals 6. So I'll go ahead, step 1, isolate. I'll add 1 to each side. Got to isolate the radical. These problems are radical. Cubic root of x squared minus 7 is equal to 7. Okay, I'm going to go ahead and raise to the appropriate power now. So I will cube each side. And we get x squared minus 7 is equal to 7 cubed. 7 cubed, 343. Okay, now I just have to go ahead and solve. So I'm going to add 7 to each side. And we get x squared is equal to 350. 350. About 350. Loch Ness Monster. Okay, so I'll take the square root of each side in order to go ahead and solve. And we get x is equal to plus or minus the square root of 350. So I honestly would be okay with that. If you want to go ahead and simplify, you actually can break down 350. 350, that's 25. Like the 50s, the 25, 50, 75, all of those are divisible by 25. And I know 25 is a perfect square. So that's 25 times 4, 8, 12, 14. 14. Winner, winner. So then this gives us plus or minus 5 root 14. Perfect. Perfect. Okay, so 2 possible answers. Now you have to go ahead and check. And don't watch. You're just gonna be like, how do I do this? For years, this problem always messes with my students. So I'm gonna do, you can do both. Watch, I'll do a plus and a minus 5 root 14 quantities squared. Is that legal? I will make it legal. Nice little Star Wars reference there for you. Okay, so I'm going to square both sides. Because it's positive and negative, when I square it, they're both going to be positive. Okay, so you might be asking yourself, well, what the heck is 5 root 14 squared? Well, didn't we just do this? 5 root 14, right? That is 350. It's the same thing as the square root of 350. So this is the cubic root of 350 minus 7. And 350 minus 7 is 343. What's the cubic root of 343? Well, we just did it. Remember, we're kind of almost working backwards. That's 7. We get 7 minus 1. Is that 6? It is. So plus or minus 5 root 14 is the solution. Awesome, Nick. Exactly. I am the Senate. Yep. Prequels have the best memes. I don't think the prequels are the best. You know, I grew up watching the original trilogy, so I'm like, you know. But the prequels are pretty sweet. Okay, here's a practice problem. Please try this one. Go ahead and pause the video, solve this, and I'm going to show the answer here in a second. Okay, hopefully you pause the video. Here is the solution. X equals -5 and +5. We'll cube each side. We get x squared plus 2 is equal to 27. Subtract 2 on each side, getting x squared is equal to 25. Square root of 25 is plus or minus 5. And when checking, it works out. So that is it. That's going to do it for this lesson. Closure question, just something to think about, food for thought. Which of the following types of solutions will always be extraneous when solving a radical equation? Rational numbers? Well, no, those are like integers. Those won't be a problem. Irrational? Well, we just saw 5 times root 14. Okay, you can have irrational solutions. And imaginary solutions? No. No imaginary solutions. We like to keep it real, right? Sorry for the dad joke. All right. Hey, that's going to do it for this recording on solving cube roots of equations algebraically.